Hello, hi, I'm Punita here from Huawei Global Training Center, and today we're going to discuss about the content Massive MIMO Site Solution Part 6. So what is Massive MIMO? So Massive MIMO uses a large number of antenna arrays to perform 3D beamforming and multi-layer multi-user multiplexing, significantly improve the system capacity and the 3D coverage. So it's highly integrated with antenna, RRU, combiner and jumper. We are using Massive MIMO. So higher MIMO, more TX and more RX. And it's using a beamforming concept. So we have a finer coverage here and we are using AAU system, RU and AEU. This is the antenna system advantages, active antenna system advantages. So what is the difference between traditional MIMO and Massive MIMO? So Massive MIMO is widely regarded as a key update of multi-antenna technology in the 4.5G era. It uses large number of antenna arrays to perform 3D beamforming and multi-layer and multi-user multiplexing, significantly improving the system capacity. So over here, we can see from the traditional MIMO, we have BBU, RRU and antenna. So number of antennas is less than 8. We have RRU and BBU. However, when we have Massive MIMO, we only have BBU and AAU module. So AAU is already integrated with an antenna system. So it's AAU plus RU with a BBU system. So what are the benefits? So we have some features here that we need to implement or activate, and there are some benefits. So if you are using the Massive MIMO feature, it will improve in terms of the power gains and array gains. For uplink 64 antenna receive diversity for uplink control channel, PRACH random access channel and PUSCH shared channel, it will improve the diversity gain. And if you are using a feature of downlink 64 antenna and 3D beamforming, it will help on the beamforming gain. So all of them are basically going to enable the eNode B to adjust broadcast beam, downlink traffic beam on both horizontal and vertical planes. So this will achieve uplink and downlink coverage performance better than the 88R multi-pearl antenna technologies. So gain is more significant on vertical plane. It also offers more power gain, array gains, diversity gains and improve single user link quality. So if we are using the feature of downlink 8 layers and multi-user beamforming, so it will improve the multiplexing gain. And if you are using the downlink 16 layer concept with multi-user beamforming, it will improve the multiplexing gain. So the benefits of this Massive MIMO supports up to 16 layers for downlink multi-user beamforming, which delivers 7 times as much of theoretical downlink peak throughput as downlink 2x2 MIMO in 88R networking scenario. So for the feature of uplink 2x64 multi-user MIMO, so we are going to improve the multiplexing gain. Uplink 4x64 multi-user MIMO, and number 8 uplink, we have 8 layers, 64 multi-user MIMO. All are to improve the multiple gain. So the benefit of this Massive MIMO support up to 8 layers for uplink multi-user MIMO with theoretical uplink throughput approximately 8 times that provided by 2 users of uplink in 88R networking scenarios. So it both helps on the uplink and downlink throughput and also the quality over here. So what are the application scenarios? So this can be applied at hotspot coverage area. In typical hotspot area, user density is high. Many online UEs create extremely strong demand for capacity in both uplink and downlink. Typical hotspot include dense urban area, central business district, public squares and stadium. So Massive MIMO can effectively improve system capacity through spatial multiplexing. So up to 8 layers in the uplink massive multi-user MIMO pairing and up to 16 layers in the downlink. So we can use uplink 8 layers and downlink we can use 16 layers of multi-user MIMO. So it will perform the beamforming pairing, significantly improve the cell throughput and meet capacity demands in hotspot area. So how about tall building coverage? For tall building, Users are distributed across many floors, and a normal site cannot extend coverage vertically very far. So the vertical beam width is approximately 6.5 degrees, makes it impossible for a traditional site to cover multiple floors. So for this case, Massive MIMO will enable the eNodeB to adjust the vertical broadcast beam width up to 35 degrees, enhancing vertical coverage of broadcast beam. In this way, more floors can be covered by a single site. So Massive MIMO helps to strengthen the power, array, diversity gain, and enables energy to be more concentrated by implementing 3D beamforming on traffic beams. The gains effectively offset the propagation and penetration losses and improve link quality of indoor UEs in tall building scenario. So let's look into the related hardware of TDD Massive MIMO. So we can use AAU 3270, 3271, 64T64R with 120 watts and 100 watts. So BBU 3910 will be used with UBBP EM. They have two carriers with 20 megahertz. So this is the hardware. And for FDD Massive MIMO, we can use AAU 5711A module, 32T and 32R, 160 watts, BBU 39110, UBBPG2A model, 3 cell by 20 megahertz, and UBBPG3 with 6 cells with 20 megahertz, 32T and 32R. This is also another Massive MIMO solution. So Q&A session. If the Massive multi-user MIMO is used, the UE speed will be double. So this statement is false. So for Massive MIMO site solution, we have discussed about Massive MIMO, difference between traditional MIMO and Massive MIMO, benefits, application scenarios, and related hardware of TDD Massive MIMO and related hardware of FDD Massive MIMO. That's all from me. Hope you enjoyed the session. Thank you and bye.